My name is Mark Murphy, and I'm here to talk to you about Android development. Now, presumably, most of you who are here are new to Android development. You maybe haven't done mobile development yet. Maybe you've done mobile development but for other fruit-flavored platforms. In which case, this is a great presentation for you. We will cover an overview of how Android apps are put together, so you can have some idea of what you will be dealing with. But this is, of course, a wonderful area to get into. We've shipped 1 billion Android devices and more so far. In fact, probably enough more that we're probably up to 1 billion users of Android devices by about now. And so there are a lot of people out there for whom you can get your apps together. Some of you may already know Android development and are here because you thought this was the North Rotunda. This is the South Rotunda. North Rotunda is the other end of the hall. I promise that I will do my level best to intersperse enough humor to keep you from falling asleep, though if you do fall asleep, we reserve the right to poke you in the ribs if you start snoring. A few administrative things before we get started. You were all given thumb drives when you got here, which purport to contain a copy of these slides. They contain a copy of these slides from about 2 weeks ago. I was editing these slides yesterday. There will be a QR code and URL at the end that you'll be able to download the exact set of slides that I'm going to be showing you here. If you're the sort who you can't attend a presentation without having the slides right in front of you, speakerdeck.com/commons guy, that's me, and you'll be able to get the presentation from there. This presentation is being recorded in front of a live studio audience, so pay no attention to that camera in the back, other than those of you who are kind of dead center in the room. If you do feel the need to get up and leave, could you maybe like put the ball out or something? I'm sure they'd appreciate it, not blocking the camera. If you have questions anywhere along the lines, raise your hands, wave frantically, throw soft objects at me, whatever it takes to get my attention. So if you throw things at me, if there would be things that are non-staining, I would appreciate it. And with that, let's start talking more about Android. I'm going to spend most of the time of this presentation talking about the traditional Android development model. That involves healthy doses of Java, XML, and other things. We will spend some time, though, on other development environments that you can use in order to create your Android applications. If, for one reason or another, you do not feel that the Java approach that I'm outlining is necessarily your cup of proverbial tea. But again, most Android development is based off of Java. And that's where, if you go to the Play Store, 1 million plus apps out on the Play Store, and that easily 3/4 of them are going to be traditional Java-based applications. Games is probably the biggest segment, and that which will not necessarily be using Java directly. They may be using other toolkits, which are in turn based on things like native code engines. But most apps is going to be focused on Java. Quick show of hands, how many of you speak at the Java? Okay, those of you who raised your hands, then you at some point in time learned Java. You took a Java course, you read it from a book, and that you had the SD card implanted behind your right ear that contained a copy of core Java, whatever. And when you learned Java, you started off indubitably with a public static void main method somewhere along the line, and that which you were told was the entry point for your application. And you probably wrote inside of their system out println hello world. That's the way you create a traditional Java application. But lots of Java development doesn't even do that. Many times when we're creating something in Java, it's really more of almost a plug-in to a larger framework. We are plugging into the Java web server or something like that for our web applications. In which case, we're not writing the main. Somebody else wrote the main. It's in that framework we're plugging into. That's the same approach we take here in Android. We don't write a public static void main method anywhere. Frankly, I haven't even run into the public static void main method. I'm not even sure there is one in Android. There could be. And that we certainly don't do it. Instead, what we do is we create a basket of components. And we tell Android, through some metadata, hey, I have these components. Let's let the user do things with them. There are four major types of these components. The one that people tend to focus on is the activity. This is your coarse unit of user interface, roughly analogous to your screen, your page, your window, whatever terminology you're used to from other sorts of platforms and GUI frameworks and the like. An Android application can have one activity. It can have several activities, just as a web app could be a single-page web app, or it could be one that has lots of individual pages and that you are linking between. Either way works. We tend to think of Android activities as being a user transaction, that the activity is focused on a thing that the user is trying to accomplish. Disparate things tend to go in disparate activities. They don't have to, but they usually will. And so, settings versus help versus about are likely to be independent activities from whatever your main activity is. And it may be that the list of things in the main activity may wind up, or list of things in your application may wind up being a separate activity from the editing form that you're using to edit the information or things along those lines. And so you're going to be creating one or more of these. There is an activity class in Java that we will inherit from that describes what that activity is supposed to look and work like. But while activities get all the love because they are GUI and GUIs are fun, they're not the only components out there. The service in Android is designed for long-ish running background work. Things that aren't tied to the user interface, things that may even be spawning off on their own with no user interface in sight. If you're trying to set up some sort of a cron job, or you want to do something every 15 minutes or something along those lines, you will probably wind up using an Android service for that. If you're trying to perform a longish running operation like downloading that ebook that the user bought from the store that your app is providing, well, you'll probably use a service for that download, so the user isn't stuck having to sit and wait at your activity, waiting for the download to complete. They can go off and do other things like, I don't know, take a phone call, and then do other things with their device while you in the background are sitting and chugging through, downloading the material. You can use this as an integration point to third-party apps. You can say, hey, third parties, you can talk to my activities. You can link to me the same way you can link to my web pages in the web app. You can invoke my services. I will do work on your behalf, and that you tell me the work you want to get done. That's part of my public API, and I will happily go do that work for you. There is the broadcast receiver. Broadcasts are messages that flip through the device, letting us know of things that are going on. Many of those messages come from the operating system itself. Hey, the battery's getting low. You may want to change your behavior. Maybe don't do as much work periodically in the background to help the user stretch out that last little bit of battery life. Hey, we had been on Wi-Fi, but the user got in the lift, and we lost our signal. We fell over to mobile data. And you may care about that. If you have the long-running socket connection and that for your streaming audio, you're going to need to know, okay, I'm going to need to reestablish that socket and maybe do slightly different configuration, and that now that I'm on mobile data rather than Wi-Fi, choose a lower bandwidth stream or things along those lines. Also ways for applications to send and receive application-level broadcasts. Maybe part of your integration strategy with third-party apps is that you're going to send out broadcasts when certain events occur within your app that third parties may care about. If you're making that music player, maybe you're sending broadcasts indicating, hey, we just switched to the next song. So that if third parties are interested in knowing that because they want to be able to show that information to the user in addition to your app showing that information, that they have the information that they can turn around and actually show. Content providers provide content. That could be the word. And this is partly an integration point. It may be that you are trying to provide content in the form of a database structure or in the form of a stream, like a web service might do. and that you're trying to make this available to the operating system. If you want to deeply integrate with the Android search framework, you'll be able to pop up search suggestions when the user starts typing something into the global search field, and that you're going to wind up publishing one of these content providers that the operating system is going to consume in order to be able to figure out, hey, this is what we want to be able to blend into the search suggestions. Or it could be for third parties. We consume a lot of content providers that the operating system publishes. Contacts, the call log, the list of all of the indexed multimedia assets, videos, photos, audio files, that sort of thing. Voicemails, calendars, all that stuff is published to us via system-provided content providers. We consume those content providers in our apps. You can even use content providers purely within your own applications, kind of an abstraction layer. You want to hide all your database accesses behind a content provider to isolate it from the rest of the application. The rest of the application can simply deal with the opaque API that's published by that content provider, the details of all the actual SQL and all that stuff that's going on under the covers will be hidden behind that API published by that content provider. Android applications almost always have at least one activity. Whether they have any services, whether they have any broadcast receivers, whether they have any content providers, varies. Some applications will have all of these, some applications will have none of these, and all the shades of proverbial gray in between. And so it'll be up to you to decide as you are designing and implementing the application, what of these components am I going to need to be able to accomplish my aims? But again, we tend to fixate on the GUI end, and that after all, these phones and so forth, and that they've got the nice touch screens, and that we can show lots of interesting stuff to the user, receive input from the user, and so forth. And so a lot of time is spent on crafting these user interfaces. Activities are the coarse unit of user interface, the screen of the window. Widgets are the micro unit of user interface. Buttons, fields, checkboxes, radio buttons, scrolling lists, drop-down lists, all those things are going to be considered widgets. And an activity will have one or many widgets, usually on the many side. These widgets are then organized on the screen via what are known as layout managers, describing where the widgets are to be placed on this screen. There are layout managers that say, okay, we're going to have all these things be in rows or columns, so-called linear layout, giving you a box model, where you can say, okay, I want to have these in a row or a column. I want to apportion the space inside of that row or column, between these widgets in a certain way, 50% of this one, 25 and 25 for the other two, things like that. We've got layout managers that implement rules where you can position things relative to other stuff, so-called relative layout. I want to position this to be 10 pixels down and 20 pixels over from the left off to the screen itself. I want to position this widget to the right of and on the same horizontal plane as this other widget. I'm anchoring widgets to each other. Layouts that put things into tables and grids. You can create your own layout managers that implement your own business rules if you're finding it difficult to hammer your UI into the various boxes of the built-in layout manager supplied by Android. And there's plenty of third parties who create widgets and create layout managers. You'll be able to download their code, integrate it into your own apps, and that in order to be able to leverage their expertise. Usually we're going to craft these user interfaces as XML files, whether manually or through a drag and drop GUI builder, depending upon your development tools. We'll talk more about development tools in a bit. It's possible for you to be able to create your Android applications with a GUI that you're assembling purely within Java code. That's a little weird. It's along the lines of implementing your web app in assembler, but hey, it's a free country, and that you can do what you want, and so there will be people who will purely develop their UI in Java. Most developers we'll use these layout files. And we'll take a look at one of these layout files in a little bit. I'm going to fire up two of the major IDEs in Android and walk through the wizards for setting up your initial project, and we'll take a look at some of the files that get output as a result.
Is there a connection between the GWT libraries and doing manual layout in Android?
The question is there any connection between GWT and doing things, manual layout in Android and Java? They're both made by Google. Beyond that, not really. Are there similarities? Sure, because they both kind of looked at Java Swing and that, as part of their inspiration, plus a little bit of web as part of their inspiration, and so there's going to be some commonalities, but that's a little more of a fact of where they came from more so than there seems to be an intentional design decision of, okay, we're going to attempt to make these things be similar. And that I'm not aware that the GWT team talks to the Android team any more than any other two teams that Google necessarily talk to.
In case of these basic components, how can we interact with the inbuilt devices like camera or something like that?
We'll talk a little bit more about those later on, but there's a series of Java classes in general that will allow you to get at the camera, get at the accelerometer and other sorts of sensors.
Where it falls, like you have like activity services, broadcast, pro receiver, content provider, where it falls basically.
Depends on what you're doing. Frequently, it will fall in the level of activities. Like a camera, usually you've got a camera preview, and that you're showing the user on the screen what's coming in the camera lens, so they have some idea where they're pointing, and whether or not their subject is actually like centered or even visible. And in that case, an activity is going to be the one who's going to be showing that camera preview, and it is going to be the one who will then tell the underlying camera hardware, okay, the user pressed the button, go take a picture. But then processing that picture might be done by a service. Say you want to upload that to Flickr, or you want to upload that to your web service. And then you'll probably wind up doing that using a service because, well, particularly a lot of these devices, we're getting pretty big cameras now, 20 megapixel type stuff. The files are non-trivial. And so you're going to want to consider, okay, I'm going to kick off a service, tell that service, go upload this thing, and so that can keep going on even if the user bails out of my UI, either because they wanted to go do something else or they got interrupted, an incoming text message came in and they elected to tap on that. So it depends a little bit on what you're doing, and that for that system level hardware, which of these components, because lots of things tend to focus on activities, a lot of our uses of this stuff tend to focus on activities, but that's not to say that services can't use them. Of the four, those are the two most likely ones. Broadcast receivers and content providers are relatively unlikely to be addressing the hardware that way. I can't rule it out. It's the sort of thing that I'm a little off. Android also has the notion, from the UI standpoint, of what are known as fragments. Fragments were kind of glommed onto the Android framework back in Android 3.0. And that was mostly to deal with things like this tablet, which right now is telling me how much time I have left in my presentation. The tablets, and that of course have bigger screens than our phones. And we want to be able to intelligently take advantage of that space. We don't necessarily want to do what that stopwatch is doing, which is simply making everything bigger. That works fine for some apps. But in other apps, we want to do other stuff. We want to, for example, do what in Android we refer to as the master detail pattern. We have a collection of things that we're trying to show the user. A collection of restaurants, a collection of books, a collection of conference presentations, a collection of balding individuals, whatever. We want to have a list of those, and when they tap on something in that list, we want to then show details of that restaurant, that book, that conference presentation, that balding guy. Well, on the phone, we're only going to have room to probably do one of those things at a time. These screens aren't that big, even if the phones seem to get a little bit bigger each year. And that we're only going to have space to either show the list or show those details. But on a tablet, particularly held in the horizontal orientation, which tends to be the Android norm, we have room to probably show both of those. We can have the list on the left, details on the right. You tap on the entry in the list and we automatically update those details. And the nice thing about taking advantage of that screen space is we minimize the pogo stick effect of the user, tapping on something in the list, looking at the details, and needing to go back to the list to choose somebody else and going to the details and bouncing back and forth. It's all in the one screen. But we don't, as developers, want to have to create totally separate activities for all this stuff. We don't want to have duplicate code. We don't want to say, oh, okay, well, we're going to have an activity that shows the list, and an activity that shows the detail, and a third activity that's going to show both, and we route between them, between whether that's a phone or a tablet. We would like to have one bit of business logic that knows how to show that list. Whether that list is shown independently, part of a larger screen, don't care. We want to have one implementation of it. Same thing with the detail. We want to have one implementation of the detail. Whether it's shown by itself or whether it's shown as part of a larger screen, don't care. And that's the predominant reason for having fragments as a mediation layer inside of your user interface. Fragments collect a series of widgets that you're trying to reuse in different circumstances, such as phones versus tablets, where your activities could skip the fragments and work with the widgets directly, and in many activities that will be the case. But in other activities, the activity's job is mostly to look around and say, hey, how big is our screen that we're dealing with? And therefore, what am I going to present to the user right now? Am I going to present one fragment? Am I going to present two? Am I going to present three? Am I going to present two, but then when they tap on something, I'm going to do this neat little animated transition effect to slide in something else? Which is, if you've ever used, like, say, Gmail on an Android tablet, you see these panes kind of sliding in and out. That's all done via these fragments. And so fragments, from the standpoint of you getting into Android development initially, fragments are a pain. It's this extra thing that gets tossed around that if you're trying to create Hello World, you don't really need a fragment because Hello World is really supposed to be simple. But the more complicated the app, the more you're trying to target all the different screen sizes. In Android, we've got a lot of different screen sizes, and that you're more likely to want to consider those fragments. Fragments can also be handy in other circumstances. If you've used an Android device, no doubt somewhere along the line you've used an app which uses horizontal swiping to navigate content. Here I've got screenshots from Gmail. If you are looking at a conversation in Gmail, you can vertically scroll to get at all the messages in the conversation, but you can also horizontally swipe, tap and slide, and switch to the next conversation in your inbox or whatever label you happen to be looking at. And so there we are laterally moving between content via this horizontal swiping. This is probably, for any app that you encounter this in, probably implemented using a container in Android called a view pager. And view pagers are most easily used if the pages are fragments. And so you have a fragment that shows the conversation, a fragment that shows the detail in your master detail pattern, where you say, oh, okay, well, on the tablet, they can randomly access anything they want from the list. But on the phone, in addition to allowing them to go to the list, we'll also do this little horizontal swipey thing to allow them to be able to go forward and backwards through what effectively is the list without having, again, to go back out the list. They just do a little gesture. All we do is pour our user interface into a fragment and tell ViewPager, hey, here are how many pages I've got, here's the rules for the fragments to show for each one of those pages, and the framework takes care of all the horizontal swiping stuff and loading in our content at the appropriate times. And so fragments are a useful technique. You do not necessarily need them for Hello World. There's plenty of applications, particularly again in the gaming area, which won't be touching fragments at all. But the more complicated your app, the more you're going to be dealing with these multiple UI sizes and that, the more likely it is that you're going to be playing around with some fragments. The resulting flow of your app is reminiscent of the web. It's almost like some, company that did like a search engine and that was behind creating some of Android and its UI. You've got a screen, you tap on the screen, you go to something else. We've got a back button that takes you back to where you were, just like a back button in a web browser. We've got a home button, just like in the web browser, to take you to your home page, or in Android, referred to as a home screen. That's usually all taken care of for us. We as programmers don't usually care about the details of managing the back button, and we can't really get involved with managing the home button. There's ways that we can get involved in back button processing if we need it in certain circumstances. Frequently we can ignore it, but that's the flow that is set up in Android. That it is very much like navigating a website, with the users tapping, pressing back to return from where they were, pressing home when they want to go and do something else. We, as programmers, in creating all these activities, widgets, fragments, services, and so forth, we're writing Java code, along with a healthy dose of XML, though again, how much of that XML you are handwriting with all the angle brackets versus using an IDE that maybe is filling all that in for you as you type stuff into wizards and forms and such. But the XML might be generated more for you rather than you messing with it directly. And then, you can use C and C++. We'll talk more about that later on, but you can augment your predominantly Java-based app with native code if there's a use for that for one reason or another. But while we're writing Java, that's not technically what's running on the Android device. What happens when you press the run button in your IDE or otherwise tell Android to go run your code on a device or emulator is that Java code is compiled with a standard Java-C compiler, but is then cross-compiled into DevWeek. Like, you might think that DevWeek is a remote fishing village on the north coast of Iceland. That's DevWeek with an accent mark on the I. And that here, DevWeek is simply another virtual machine, like Java or any other language that uses a virtual machine. It so happens that that bytecode is something you can get readily from Java code, but it is not Java bytecode itself. We as developers don't usually have to deal with this unless we're getting really fancy and now we're trying to embed an interpreter, or that interpreter does its own just-in-time compilations. We're trying to embed JRuby or Groovy or Bean Shell or programming languages like that inside of our own apps. If they're used to generating Java bytecodes for their own just-in-time compilation, that gets to be a bit of a problem on Android, because Android doesn't run those bytecodes. Now, why Android went with DevWeek? The arguments vary, and that according to Google, they did it because of the security model. Android's based on Linux, uses the Linux kernel under the covers. They wanted to use Linux process security so that each individual app would run as its own process, and to do that, they needed to figure out how to be able to run Java-style programs in a whole lot less heap space, RAM, than you're going to be used to from your traditional JVMs, even including Java Micro Edition. There's this little company named Oracle, who bought another little company named Sun, who created Java. Oracle's contention is Google is trying to do this DevWeek thing to avoid paying licensing fees for Java ME. I'm sure Google doesn't mind not paying the licensing fees, but if you hear about the lawsuit Oracle v. Google, that's the bone of contention, that Oracle claims that Google was infringing upon intellectual property that Oracle acquired when they acquired Sun, and that pertaining to Java technology. Round one went to Google, and the appeals process was going to drag on for years. Again, we usually don't have to deal with this, but it's something to bear in mind that, hey, even though we're writing Java, technically that's not what the device is writing.
My question is that if you mentioned memory limitations in DevWeek, so if I have a body of code that's multi-threaded and works in Java, what problems do I expect to encounter when that is translated into Dolphin?
From particularly a multi-threading standpoint, most of that should behave just the same. I mean, Dolphin is, we've beaten it up for years, and that there isn't gross incompatibilities, or even, I can't even name hardly any incompatibilities in terms of standard Java code, whether it's run as Dolphin bytecode on Android versus Java bytecode on a JVM, and that the stock classes are going to behave the same way. There will be a couple of idiosyncrasies. There is a magic thread named the main application thread, and that your UI is driven through there. You want to stay off of that thread as much as you can, and that thread has a very small stack. Like, used to be 8K. I think they've actually bumped it up to maybe a robust 12 or 16K. But that particular thread is a bit magic in Android, more so than you can find in traditional Java. But in terms of the multi-threaded constructs, Android's got all of Java.util current, and so all of the linked blocking queues and executors and semaphores and utexes, all that stuff is all in there. Though do bear in mind that one of the side effects of this being, Android is that this Android is not Java SE, it is not Java EE, it is not Java ME. The class library most closely resembles Java SE, but there's vast differences. There is nothing from Swing. There is almost nothing from AWT. There's no JAX RPC. And that they basically aggressively cut down the class library, mostly to keep the bill of materials down. They want Android to be able to run on lower-end devices. The smaller the firmware can be, the less expensive the device can be, because there's that much less, silicon and whatnot that's going to be required, less disk space, and that is needed on the devices. And so therefore, while for the more core the class is, the more likely it is to exist in Android. If it exists there, it should work identically, and that there's a couple of things where Google's done some tweaks, like HTTP URL connection, and that to try to help modernize stuff behind the scenes a bit more for dealing with like SNI with SSL connections and so forth. But that's not, it's binary compatible, and that the method signatures and everything are all the same, and that you just get extra benefits potentially on Android that you might have in an equivalent JVM. In addition to our compiled Java code, we're going to have what are known as resources. Those layout XML files that I talked about, where we're describing our UI in terms of what the widgets and all that are, that our activities and fragments are showing, those are one example of these resources. Resources is basically static data that's part of our source code that's not written in a traditional programming language. Our artwork, images, and so forth are going to be resources. Menus, animations, externalized strings, and for internationalization purposes, audio clips, all that stuff gets packaged as resources and is available to us, both from other resources, so our XML layout files can reference images for like icons that we want to be able to show on the screen, and from our Java code, such as when the user taps this particular UI element, we want to play this og vorbis file, and that as kind of a beep or whatever else, and that is audio feedback. These then get organized into what are known as resource sets, saying we want to use this directory's worth of resources in certain circumstances, but perhaps not in others. Please use these strings for English. Please use these strings for Spanish. Please use these strings for Chinese. Hey, please use these layout resources for phones versus those layout resources for tablets. Or use these layout resources for portrait mode versus these other layout resources for landscape mode. And tons of other criteria. How many of those criteria you use will vary based upon app. If you're only going to deploy your app in English because this is for your 30-person company, and that all your employees speak English, and that, okay, fine. You don't necessarily worry about and that having multiple translations of your strings. And then, so you're going to be able to dial in how much of this stuff you're going to take advantage of. This is one of the ways that Android provides of dealing with fragments, not in terms of UI fragments, but in terms of fragmentation, the F word in the Android space, where we've got something like 10,000 device models. And that from everything from your traditional phones and tablets to the seatback entertainment system of the 787 Dreamliner. And so we've got all sorts of different physical characteristics of our devices. Android provides a lot of hooks for us to be able to say, okay, most of our stuff is the same. The little pieces that vary, here's where we can put them in the right buckets that Android will then load in the right stuff at runtime. Frequently in our Android apps, we don't think about the language ourselves. We just have our JavaScript layouts do its thing. So long as we've got our strings in the right files, Android will load the right ones in at runtime based upon whatever language the user has the device set up. And tying all of this together is a file known as the manifest, or more formally Android manifest.xml. Reminiscent of a web XML file or a servlet or var, this file is our table of contents. It says, hey Android, I've got these components, yo. And here's the rules under which those components should be used. Like this one activity, it's the entry point to our app. Please put an icon for that in the home screen or anything else on the device that thinks of itself as a launcher. Versus other activities which are more kind of like the inside web pages, if you will, of our app that we will link to ourselves but aren't necessarily designed for the user to get to independently, and so therefore we don't need icons for those in that home screen. Manifests also contain a lot of other rules. What's the oldest version of Android we're willing to support? What's the permissions we want to hold? Things that the user has to approve that our application can do, like talk to the internet, read our contacts, work with the camera, and so forth. What screen sizes do we support? Is this app supposed to only be for phones? Is it for phones and tablets? Is it only for tablets? And that's so that Android knows and distribution channels know what our expectations are. With that, let's talk a little bit about tools. You can use Eclipse. Eclipse is the original supported IDE for Android development. Classically the most popular IDE for Java development, open source, and that Android augments that with the Android Developer Tools, or ADT plugin, which gives Eclipse super Android powers, where now it knows how to create Android projects and wizards for creating components like activities, and knows about the Android class library for code completion, and knows how to run Android apps on devices and emulators and all that fun stuff. Welcome to Use Eclipse, and Eclipse is used by the majority of Android developers today. But you'll also hear about a new IDE called Android Studio. Android Studio was announced at last year's Google I/O conference and has been in an early access preview mode ever since. This is based off of JetBrains' IntelliJ IDEA, IDE, and that where they have taken over management of the Android plugin and are giving Android Studio all of the capabilities and more that Eclipse had. And Android Studio is going to be the primary IDE in the long haul. Right now, the tool space, therefore, is in a bit of flux. Android Studio, some people love it, some people say this was worse than Eclipse. And that how much you like Android Studio is somewhat kind of like the reciprocal of how much you like Eclipse. You think Eclipse is great, Android Studio is in. You hated Eclipse, Android Studio is a breath of fresh air. But it is still an early access preview. And so for newcomers right now, if you could maybe go into hibernation for like the next 3 months and wait for Google I/O this year and see whether or not they ship the final version, and that might not be a bad plan. And that the Android Studio still has its quirks, still has its warts, still has incomplete bits, and that they are still working heavily on it and coming out with point releases and that every so often.
Does it accept IntelliJ
Yes, as far as I know, and that there may be collisions, like for example, you can't also install the Android plugin because that's already kind of part of Android Studio. And I can't rule out the possibility that there is some IntelliJ plugin that ain't gonna play ball, and that, but generally speaking, as I understand it, that works fine. And that, because it is IntelliJ IDEA 13, and that with, just extra Android-y goodness and that.
That's interesting.
Right. And so it is, it should handle it, and I'm not an, IntelliJ guy, and so I don't know all the ins and outs. I have not heard of any, haven't heard of any screams of anguish from the community. So therefore, it's probably okay. You, of course, don't have to use either of those. You can use ordinary IntelliJ IDEA. And in fact, if you wanted to get into Android Studio eventually, and you don't have any prior experience with Eclipse, you might consider just going to IDEA with the Android plugin and working with that now until Android Studio gets to a 1.0 release. And then consider cutting over, because that cutover is going to be comparatively easy. Same key bindings and color schemes and general capabilities, project structures, and so forth. Whereas the jump from Eclipse to Android Studio, there's more significant differences in those tools. If you've been used to using NetBeans has Android capabilities with the NB Android plugin. You don't have to use an IDE at all. When I started Android development, I didn't use an IDE because Eclipse and I had a long and sordid history, mostly involving profanities. And so and when I'm not doing Android development, I'm, the command line and give me a nice editor sort of guy. And so you do not have to use an IDE. Everything that you want to do in Android development can be done outside of it. And that there are certainly things IDEs help with, but they're not essential. And you can develop using Linux OS 10 or Windows, and then you're not locked into a particular platform. There's even tools that allow you to build Android apps on Android. The AIDE, Android IDE project, and that allows you, if you want to write Android apps and that on your tablet, you can do so.
About device simulators, what do they plug into these things?
The device simulators, Android Development Tools provides an emulation engine, and they provide, the ability for you to say, okay, I want to create an emulator image that, has these screen characteristics and is running this version of Android and has this, pretend we have, such and so many megs of storage and RAM and so forth. And that's all provided by Google, and that for the IntelliJ family and for the Eclipse family, I'm not sure exactly. NetBeans is probably just working on it from the command line, and that the same way you would if you were not using an IDE at all. Various vendors might ship specialized, basically emulator images as starting points, like Amazon does with the Kindle Fire series, because the Kindle Fires are a little bit weird compared to your mainstream Android devices. They don't have things like the Play Store and Google Maps and so forth. And so they've taken the step of actually shipping emulator images that can plug into the Android emulation engine. And then so you can create your Kindle Fire images the same way as you create your standard Android images. And the IDEs then, at least the Eclipse and the IntelliJ families, know when you click run, oh, okay, do you want to run it on this emulator image you already have it running? Do you want to run it on this device that you're plugged in with a USB cable? Do you want to start up a new emulator image because you didn't have one running already? It handles all that for you. And with that, let's talk real briefly, because I'm running late, and that about Hello World. Eclipse. If you've got the Android Developer Tools plugin, when you go in to create a new project, you're going to have an option for creating an Android application project. Android is now part of our world, and it gives you a wizard to start describing your initial project. You give the application a name, what the user is going to wind up seeing, on the device, in the Play Store, and so forth. You can change this later on, and that can provide a starter name at the outset. You provide what the name that Eclipse is going to know the project as, so in your Project Explorer, your list of all your available projects, that's the name that Eclipse is going to know it as. You provide a Java package name. That package name partly is for code generation. Code-generated classes will live in this Java package. More importantly, this is a unique identifier for your application. You cannot have two apps on the same device with the same package name. You cannot have two apps on the Play Store with the same package name. Which means you're going to want to probably follow the standard Java naming convention of a reverse domain name. And that, pick a domain name you own, start off with that. And so I run a company named CommonsWare. And so com.commonsware.foobar means that it's unlikely that somebody is accidentally going to collide with that name, except of course I publish a book and several hundred sample projects which people tend to import and don't necessarily change the names, and so I happen to be in a weird space, but for you guys it's less of a problem. And so you choose something that is likely to eliminate accidental collision. Ask a bunch of other questions. How old of Android am I willing to support? Android's changed over the years. We've added new APIs, new classes and methods that we can take advantage of. If there's some stuff that we gotta have, otherwise our app isn't gonna make any sense, then we specify, okay, how old are we willing to go? I'm willing to go back to Android 2.2, for example. Google publishes charts, you've probably seen on various Android blogs, and that's showing the space of Android devices and what percentage of them are running Android OS levels. At this point in time, approximately 99% of Android devices are running Android 2.2 or higher. But you, of course, are willing to choose, any level you want, all the way back to API level 1, and that, which would be just crazy. Target SDK, basically we're saying what version of Android are we thinking of when we're writing this code for forward compatibility. When our application winds up running on a newer device, Android 5.0 Lima Bean comes out, and not that Lima Beans are a tasty treat, but whatever. And that it sees, oh, we were thinking of Android 4.4 when we wrote this app. It's going to maybe behave a little bit more like what Android 4.4 did in certain areas to maximize compatibility. And that whereas an app that had said, I'm thinking of Android 5.0, it behaves more naturally. So that Android's trying to, between these, handle forward and backwards compatibility so that our apps are going to be able to run on the maximum number of devices with the minimum amount of code. What version of the class libraries do we want to compile with? We can, in our Java code, opt out of using some of those based on the device we're running on and say, okay, well, we're on an older device, so we're going to branch away from this code path that would have us use these new fancy stuff. We'll go do something else instead. But that's going to, the compile is going to say, hey, what classes and methods should be available to us that Eclipse, as we're working on our project, will know about, and we're going to be able to reference directly. Theme basically says, hey, what's our general UI look and feel? The default is we're going to have a light colored background, but that the toolbar or action bar that appears at the top of the screen, that's going to be dark as a contrast. There's a handful of stock themes. You can create your own and use this just as a starting point, and that in order to have the app look the way you want. Create a custom launcher icon if you are ready to provide artwork for what your little icon should be on that home screen or in the Play Store and that. You can go through a wizard that will help you scale that artwork for various screen densities, because Android devices have screen densities ranging from a low of 120 dots per inch to a high of 480, and I think there's going to be a 640 before the year is out. And so you may want to have different artwork for those different densities. Create activity. Do you want the wizard to help create your first starter activity? Or do you want to skip that? You're just going to do all that yourself. Do you want this to be a library? Not creating an app, but creating a library that other apps consume as part of a reuse model. Plus a bunch of Eclipse stuff. Where do you want the code to reside in the file system? And do you want to organize this into one of your working sets or what have you? If you said you wanted to create an activity, you were given a dizzying array of 3 templates to choose from. They're going to open this up someday, and that, in which case the array could actually become somewhat more dizzying, but you're given choices for what the starter code should look like for that template. There's a blank activity, which, as we'll see in a moment, is not terribly blank, and then a full screen activity, which says, hey, we're going to allow the user to be able to get rid of that little top toolbar, get rid of that home and back button from the screen, because we're creating a game or a video player or something where we want to minimize that sort of Chrome. We want to have all of the screen real estate dedicated to us. It even comes with a template for dealing with that master detail pattern, where it will set things up to be able to say, okay, well, I've got 2 fragments, one for showing a list of stuff, one for showing the details of an individual piece of stuff, for whatever the stuff is, and we'll rig things up so that those will be shown one at a time on phones, side by side, on tablets, particularly in landscape. And for your template that you chose, it's going to ask a few additional detailed questions. What's the Java class name that this activity should be known as? The layout resources that should be code generated as your starting points. What are the names of those files and that you want to use? What sort of navigation do you want to have in this? Do you want to have it be plain? Do you want to have, a set of tabs plus that horizontal swiping that I talked about earlier? Do you want to have, a drop-down list in that toolbar, be able to move, say, between different accounts, stuff like that? Again, these are just templates. A lot of the code that winds up getting generated, you're probably going to wind up ripping out by the roots. But just as you start with that Word template and then you edit just as you see fit, same game here.
So does this all produce, like, in addition to code, XML files and things? If I want to change my mind after I go through the template hoppers.
You can't go through that wizard again. And so it depends upon the nature of the change. If you want to change say you don't want the display name of your app to be foobar, you want it to be something else, super turbo foobar, there's a file you'll go to which contains the English language version of that string. And then, of course, you're going to need to think about, do I need to translate that? What is super turbo foobar in Chinese, for example? On the other hand, let's say that, I chose, and that horizontal swiping with the tabs, GUI designer said, I don't want those tabs, get rid of those. That may require somewhat more work in order to be able to tease out the right portions of what was code generated for you, and it's going to require you to understand a lot more about what actually got generated and what it means and so forth. And so it depends a little bit upon the theme that's in there. A lot of them are just like little entries in an XML file somewhere. You change a couple characters and you're done. Some of them may be a bit more involved. What we wind up with then is an Eclipse project. foobar automatically launches the drag and drop GUI builder, showing the code-generated, highly sophisticated Hello World app that we're given as our starting point, where we can go in and drag other widgets onto here, see the outline of the widgets and containers that we have on there, be able to tap on these things, be able to manipulate properties of them, reminiscent of drag and drop GUI builders you may have used elsewhere. But you can always drop down to the XML. If there are things you can't quite figure out how to get the drag and drop GUI builder to do what you want, you can always drop back to the XML, manipulate it directly. Changes you make here will be automatically reflected in the drag and drop preview area when you flip back to that tab, and vice versa. We're given our initial class, code generated into our Java package, containing more stuff than an activity that is a blank activity should have. I'm having a bit of a spirited debate with the Google team, and that if by debate you mean me yelling and them just sitting there. Because I am on the pointy end of the spear for helping a lot of developers with support, and I'm seeing a lot of developers saying, hey, this blank activity gave me all this stuff. I don't want it. Make it go away. And helping them figure out how to do just that. But it gives us an activity, sets up an initial fragment for us, so that highly sophisticated hello world is actually going to be managed by one of these fragments, and so forth. In addition to giving us that res directory containing all sorts of resources, starter icons, those layouts, strings file that contains things like that foobar app name. So I want to go super turbo foobar. I go here and say super turbo foobar, and that now everywhere I go, that should have automatically changed to be super turbo foobar, and that the another bug to report.
So is that signs in the XML just referencing resources?
Yes, and that in those XML files, if you see at like string / something that says, hey, go find the string resource whose name is whatever, and then on the fly at runtime, Android's going to say, oh wait, we're on a Vietnamese device. Do we have a Vietnamese translation of this string? If yes, use it. If not, do we have a default translation of this string? If yes, use it. If not, help. And so you don't in your code think Vietnamese versus English. Usually you just say, I want the string name, whatever, and the Android substitutes in the appropriate string. Android Studio is going to work much the same way. You create a new project. It's going to ask most of the same questions as before, other than it also adds in this notion of a module name. An idea project is decomposed into one or more modules representing, say, an app and associated libraries, and that you need to give a name for the starter module, and that they suggest app if you're creating an app. But you can specify where do I want the file to go, what's my package name, all those same sorts of questions as before. It also has these checkboxes for support mode saying what additional pieces, additional libraries that Google ships do you want to link into your app. I mentioned that fragments were added in Android 3.0, but there's a backport of fragments that Google has published and allow you to use the same fragment concept all the way back to Android 1.6. If you're supporting Android 1.6 today, you're either crazy, a saint, or both. And so but if I want to use that, because I'm still trying to support Android 2.3, which still has 20-ish% of the Android device market, I can check off, oh yeah, I want to use that fragments backport, and Android will, the wizard here will automatically set up all the hooks so that library is available for you. Once again, you can add that in later on. It's not like you have to make that decision once and you're locked into it for all time. It's a wizard. They're just providing you with a helpful way of getting things set up initially. Once again, you're given your choice of your templates to go through. You're asked various bits of things. The templates aren't necessarily in sync, and so the Android Studio version of the blank activity template does not automatically set up a fragment for you. And therefore, it's not asking for that fragment layout name that the Eclipse wizard did. But otherwise, it gives you largely the same sorts of, actually, hidden here is under the additional features area. And when you click finish, you wait a little while, and that it takes a bit longer than Eclipse is. But eventually that should pop up an IDE. Eventually that should pop up a fully visible, there we go. So now we get the same basic thing. It's code generated, or source code, or layouts for us. It's got its own version of the GUI builder, a bit more sophisticated than what we had inside of Eclipse, in that we actually get it framed with a device screenshot so we can see what it looks like complete with the rest of the phone, and so forth. But otherwise the same basic capabilities, but again, Android Studio is kind of the long-term direction.
Is that gray with gray permanent or
Oh no, this is the Darkula theme, I believe, and that the you can choose and create your own custom theme, and there's a dozen or so stock ones, and I'm sure there's ones you can download, and so the I mean that is up to you. For whatever reason, Darkula is fairly popular. Anyway, some under the covers stuff. Android links all of these components together through a quasi-message bus known as the intent system. When we want to start up one of our other activities, or start up a third-party activity, like we've got this PDF file, we'd like some PDF viewer on the device to go be able to view it, we're going to create an intent describing what we want. Hey, Android, I've got this thing, it's a file, it's located here, its MIME type is application/PDF, I want you to go view it, make it happen. Much along the lines of how HTTP is verb and URI, I'm getting an image I am posting to a script, I'm putting to a resource. The intent system in many cases in Android works much the same way, with a whole lot more verbs, like hundreds of verbs, let alone ones that third parties can go in and create. You can create your own intent structures, and that whether for purely internal use or for integration with third parties. So we want to start an activity, kick off one of those services, send one of those broadcasts. Those are all handled through this message bus of the intent system. And so we'll be using that for whether it is starting up our own components or talking to third-party components. You wind up using these intents and that's saying, okay, here's what I want, here's additional details, extra data that we want to pass along in the request that can be used by that receiving component, much like query parameters on a URL that you link to in a web app, and so forth. And Android provides common structures that apps can opt into. I can say I want to send this thing. If you've ever used an Android app and you've seen a little share icon or menu choice in that, and it pops up this list of things that can share some piece of content that you chose in an app, that's all done through kind of a generic mechanism. That app is saying, hey, the user wants to be able to send this piece of content to somebody. Android is then going to sift through the device and say, who's all advertised? Do they have an activity that knows how to send things of that MIME type or whatever? Send them on the list. User can choose which one they want to go to. We writing the app neither know nor care what apps are all installed that can handle that request. And then we just ask the operating system, hey, make it happen, and the operating system and the user then decide who's going to fulfill that request, and then that other app gets started and goes off and does the work. So viewing, sending, and that all these sorts of common verbs, in addition to more single-purpose ones, custom ones that other apps develop, and so forth. So there's a whole language of these intents that we can use for integration. And one of the hallmarks of Android development, kind of going back to the Linux and Unix underpinnings, and that is, link things together, and that, we're not using pipe operators on a command line, but it's the same sort of concept, that you want to make it easy to be able to hook up to other apps to be able to handle things like viewing a PDF that's more than your app's mission statement really calls for, but that the user needs to have happen. Android bakes in SQLite as a relational database engine, the same SQLite that you might have played with in your Ruby and Rails apps, and that sits behind your Firefox bookmarks and used all over the place. It may at this point be the most popular embedded database engine. And then you can use this in Android, SQL compliant, with quirks, because every SQL database has quirks. You're going to be able to go in and say, all right, I want to set up my tables, manipulate those standard SQL statements and so on. You've got ordinary files. It can either be on so-called internal storage, which says it's a spot that's private for your app. Other apps and the user cannot readily get at those files. External storage is what you get when you plug the device in through USB cable and that to a host computer. It shows up as a drive letter or volume or something. You can put files out there, specifically for things that the user should have independent access to. They should be able to copy it off the device and attach it to an email on their desktop or what have you. There's also a shared preference system, equivalent of your Windows registry or big files and that for little bits of data, particularly things that are like user settings. There's a whole GUI framework for collecting those that looks a whole lot like the settings app in Android to help provide common touch points. Android does not have the GUI design guidelines that say Apple publishes for iOS, let alone enforcing those, and that what they take more of the carrot approach rather than the stick. And that they say, hey, we've got these facilities that will simplify your life, they'll simplify the user's life, we really encourage you to use them. If you don't, okay. And that don't blame us for the 1-star ratings. You'll want to put an icon in the status bar to let the user know about something that you did in the background. You've got mail. Things like that, you can do those. Those aren't limited to system apps. You can say, oh, I also want to play a ringtone, or I want to vibrate the device. Or, hey, when the user then taps on that thing, they slide down the notification drawer and tap on an entry. Hey, here's what I want to go ahead and happen. Please start up this particular activity of mine so they can go process the event, such as I completed the download, now let's go read the ebook or whatever. You want to be able to handle multimedia? No problem. Android's got a full multimedia engine, audio, video, local and streaming, recording and playback. And so you're going to be able to go in there and set up what you need. The multimedia engine has its quirks, it has its limitations in terms of particular codecs and streaming protocols and whatnot that it speaks natively. And so depending upon your needs, the multimedia engine may be perfect, it may be horrible, or something in between. Usually something in between. You want to figure out where the device is, in hopes that perhaps the user is nearby. You can hook up to GPS, Wi-Fi proximity, cell tower triangulation, and that is technologies to be able to figure out where the device is. You can choose to use one or all of these, different, of course, power characteristics and accuracy, and so forth. You can dial in, or you can let the user choose what they want to use. You want to integrate maps. Most Android devices have Google Maps built in, and you can embed Google Maps into your application. So you can draw on them, put your little push pins and draw your lines and your shaded areas and so forth to accomplish your business aims. Or there's third-party mapping engines, particularly if you want to ship your app to devices like the Kindle Fire, like the Nokia X series that don't have Google Maps built in, so you can support those devices as well. Sensors. Varying sensor suites on these devices. More and more sensors showing up in newer Android versions. So you can detect the movement of the device, whether or not we should be in some sort of night mode based on ambient light, and what's the external temperature, what's the barometric pressure, and that all those sorts of things may be available to you. Varies by device. Query the device to figure out what sensors it requires. You can put in the manifest. My app needs barometric pressure. Do not ship me to devices that lack that sensor, because otherwise my app is useless and I don't want to have frustrated potential users. Obviously, many of these are phones. You can figure out if the phone is in use. What cell towers are we talking to? Manipulate the Wi-Fi. Communicate over Bluetooth. NFC, near-field communication for things like the Google Wallet tap on the payment terminal, or the put your two phones back to back to share the playlist, like you see in some of those Samsung television commercials and that. The cameras, USB accessories, the list goes on and on of the things that you can hook in. At the end of the day, when you are written your code, what you get out of the back end of the compilation engine is an APK file, the Android application package. This is the Android executable insofar as it is the thing that you will upload to the Play Store or other distribution engines, or otherwise get to the prospective users. In reality, it's a zip file, much like jar files or zip files. When it's digitally signed, We create a self-signed certificate to use to sign these so we can determine, are these two apps written by the same developer? If so, they can have optionally some additional abilities to work with each other that two independently authored apps would not have. You can distribute these APK files however you want. Predominantly, people think of the Play Store. That's Google's marketplace, formerly known as the Android market. One-time $25 US setup fee, and you're good to go. You upload your app, it'll be automatically checked by the bouncer, but there is no manual review process the way you have for curated stores like the iOS App Store. Just has its pros and its cons, and that we can talk about those pros and cons at some other time. But there's other places. Amazon App Store for Android not only is on the Kindle Fire series, but they distribute that preloaded on some other devices and is available as a download for any Android device that wants to have it. So there's a lot of people in the Amazon App Store for Android. You can ship through there. Nokia has their App Store for the X series. Samsung has a dedicated App Store in addition to the Play Store for promoting apps to Samsung device users and so forth. And so you've got a variety of channels in addition to distributing the APK file yourself for internal use within an enterprise or whatever. But not all of you are going to drink the Java Kool-Aid. You are going to think that you want to write in something else. The next most popular way of doing Android apps is in some form of native code. The problem is that native tends to get used in two different ways in Android. If you are talking native as compared to Java code, that native code is referring to C and C++. Except when you're talking about Java being the native code, in which case the alternative is something that's more based off of web assets. And so unfortunately, we tend to overload the native term. Usually in Android development circles, we are going to refer to native code as being C and C++, and that, but in the tech media, native tends to be referred to as, Java would be considered native, as in contrast to HTML5 and so-called hybrid apps. The native development kit, the NDK, is an additional download you can get from Google, which embeds C and C++ capabilities into your toolkit. And then mostly for command line work, there is some hooks into Eclipse. I don't think they've got it hooked up yet to Android Studio. It's on their to-do list. And that this will allow you to write C and C++ code as part of your application, either as an adjunct to Java code. Say, for example, there's a particular algorithm that you already have a C and C++ implementation for from somewhere else, and you want to reuse that code rather than re-implement it. Or it's a particular algorithm that from a performance standpoint, even the just-in-time compiler resolving isn't enough. You really want to be able to run on bare metal. And that you can even create a whole app this way. Many games have not stitched Java in them, and that it's C and C++ pretty much from the beginning in terms of what the developers are writing, whether directly or indirectly through a game engine. And so there are reasons for using them. The downsides is that Android is not a single CPU architecture. Most Android devices are running an ARM CPU of varying vintage. Some devices, some of the Samsung Galaxy Tab series, for example, and that are powered by x86 CPUs. The MIPS consortium has Android ported to them. MIPS you'll see in devices like possibly that projector, and DVD players, television set-top boxes, and the like. And the MIPS consortium is desperately looking for people to write apps and that for their devices. And so you're going to need to take that into account. Your code is going to need to be portable across CPU architectures if you want to support all of them. And of course, C and C++, if you didn't like Java, I'm not quite sure why you'd like C and C++, but hey, we're a big tent sort of ecosystem, and that you like C and C++ over Java, and that more power to you, and that you're welcome to develop.
So are you compiling to multiple, you're compiling the C to multiple versions, which you then ship with the application, is how you do that?
Correct. The NDK will handle the cross-compiling for you, and it will bake into your app whatever CPU architectures you ask for. And so if you say, I want to support both ARM and x86, you will have Linux-style.so files, and that for ARM and for x86 inside of your APK file. Making sure that the code is going to work work on both of those architectures. It's your job. But they'll handle the cross-compilation for you. The NDK includes a copy of the GCC compiler and that with all the targets necessary to support the Android architecture. So whether you were extending an existing app or writing a complete app, which is mostly, again, for your OpenGL and OpenSL environments tending to be games, and that you can use C and C++. Can, of course, go more web. Write HTML5. Question, come back.
It's not just a question, more of a comment. Another con is debugging.
Yeah, I kind of, everything for dealing with the fact that, hey, you know, we've got different languages and different CPU architectures, and that, yes, it is going to make debugging painful. And that I haven't done serious C and C++ work since 2000, and that so I don't do too much with the NDK, and therefore haven't run into too much of that myself. But yes, I'm not the least bit surprised that yes, debugging is going to be a pain, simply because the IDEs are mostly optimized for debugging Java and don't necessarily have the ability to just seamlessly step into that native code. You know, you can use things to cache manifest, you know, newer HTML5 specifications eventually, and that for being able to say, I want to have some of my web assets cached offline so that the app can still work, even though you are on the plane and you don't have internet access or something like that. Android's WebView, which is the widget that's responsible for being able to render web content, has various other pieces of the HTML5 specification on that. But HTML5 is a fairly large basket of standards in various stages of completion. Different Android versions will support different levels of HTML5, and so you'll need to kind of, you know, do your homework to determine what things you're going to be able to leverage versus ones you won't. Good news, it's web. You may already have a team that knows that stuff. And it's cross-platform, or at least more so than writing a Java app in Android. But, you know, you're going to have to think about touchscreens, make sure you're using, you know, JQ Touch, Center Touch, some other library and that can maybe handle touchscreen events. And you're going to need to think about discoverability. You know, are people going to realize that if they bookmark your website, that all of a sudden, magically, that's kind of like an app, and that they're going to be able to use it offline? For better and for worse, users have gotten into the mindset of these app stores. And therefore, if you're not in an app store, they're going to, you know, are you really there and available for them to use? Trying to bridge that gap are the so-called hybrid apps, where you are using something like PhoneGap to be able to say, okay, I want to take all those web assets, but I still want an APK in the end that I can distribute through the Play Store. These also will then try to help backfill in some capabilities that the devices have that maybe aren't available in an HTML5 specification yet, or aren't available in HTML5 universally across the mobile platforms and so forth. And so these are certainly a possibility. The good news, you get the same distribution capabilities as you get with those native apps. You get into the Play Store, the App Store, and so forth. But, you know, the native UI isn't, you know, the UI of your app is not going to look the same as a native UI from an Android app. It's going to look like a web app. In many circumstances, that's not a problem. Some circumstances, that is going to be a problem. Where the audience is going to think that your app, you know, is being weird simply because you happen to be using HTML, CSS, and JavaScript to render the UI rather than native widgets. And despite the ability of, say, a PhoneGap environment to be augmented by plugins, you still can't do everything that you can do with a native app. And that there's going to be limits that you're not going to be able to get to, and that without slinging some Java. Into games, loads of game development libraries support Android, possibly in addition to other targets. Some of these libraries, like AndEngine and that, are Android specific, you know, layered on top of the low-level graphics primitives in that in Android in order to be able to handle your particle physics and, you know, all that jazz. Many more cross-platform that are aiming to allow you to be able to write the app once, run it on iOS and Android and perhaps elsewhere, and that with minimum code change. It seems like every month a new cross-platform option shows up. And that some have been around for a while. Titanium Mobile says, okay, we're going to leverage the JavaScript experience on your team, but to avoid the HTML not being a native UI thing, you're basically writing you're writing widgets and containers in JavaScript, and we will then transparently translate that to an Android native UI, an iOS native UI, and so forth. Adobe Air, Xamarin, if you are into the .NET world, and that, as I suspect many of you are, and that Xamarin, and that's got plugins for being able to go in and target Android and other mobile platforms. Sencha Touch, in addition to being a widget library that StackOverflow also has their own sort of PhoneGap style environment for being able to package up those Sencha apps. Plenty of others that are available. You may have heard of App Inventor. This is a tool that Google released and that was designed mostly for education purposes. Google discontinued it and handed off to the MIT Media Lab. And that this is not only drag and drop from a GUI, but drag and drop from a programming standpoint. Blocks that you were dragging around and plugging together like puzzle pieces. And that historically the apps weren't designed to be distributed. I don't know whether or not they have improved upon that, since it got to the Media Lab, and that it's something to consider particularly, and that if you've got a non-programming sort of audience. And there's countless app generators in that out on the web where you fill in the blanks, you push the button, and bing, the APK spits out the back end. The apps aren't particularly sophisticated. They are mostly there for your restaurant who decides, yes, I need to have an app that has my menu and my hours of operation and so forth, and that be more so than necessarily trying to create arbitrary stuff. To decide what you're going to do, think about the distribution. If it's going to the public, if you are planning on shipping on the Play Store, UI fidelity tends to be more of an issue than it is for, say, internal consumption. Enterprise applications, we have a long history of them looking like crap. And so therefore, the concerns of, gee, this doesn't look exactly like a native UI, not going to necessarily be a high priority of management. And so, depending upon your audience, certain options may or may not be great solutions. What are we going to run on? If we know we're running on Android because this is an enterprise app, we distributed Android devices to the field sales force or whatever, we know what it's going to be on, well, cross-platform maybe isn't a huge concern. If it's more of a BYOD, a little public distribution, now you've got to think about, okay, am I going to need to think about cross-platform? And am I going to do that as multiple native implementations? Or am I going to try to choose a cross-platform environment to minimize coding effort at the cost of perhaps limited capabilities and functionality, not necessarily native UI fidelity and so forth. The deeper you want to get into the device capabilities, the more likely it is you're going to need to do a native app. You want to get to the camera and the accelerometer. Some toolkits and cross-platform frameworks may give that to you, many won't. And that you'll need to check and determine, okay, what am I going to need? What are the cross-platform frameworks going to give me? Throw out the ones that don't match to give you the subset to choose from. And from there, you're going to try to usually pick something that's going to be amenable to your team. If you've got a lot of web developers in shop, that may lead you more in the HTML5 hybrid space, and that compared to doing a native Java app, all else being equal. All else is infrequently equal. And that something else may well steer you in the direction of native Java or C, C++ or whatever. But, you can pick and choose depending upon your team's knowledge and experience. In terms of where to learn more, developer.android.com is the home of Android, and that is a Google-run website. This is where you download Eclipse with the Android Developer Tools plugin. This is where you download Android Studio. This is where you download the NDK. This is where you see the Java docs of the class libraries, read the training guides, read up all the other prose that's out on there. StackOverflow, of course, is a fairly popular resource. And that I tend to hang out a little bit on StackOverflow. I've answered 12,209 questions on StackOverflow so far. That's out of about 460,000. And that the Android's, I think, a top 5 tag now on StackOverflow. And that certainly there are worse places for you to turn for your help. But beyond that, particularly, for places where English isn't necessarily their primary language, I maintain a roster of other Q&A Android sites out at www.anglobe.com, because StackOverflow is wonderful, but English is a single point of failure. There's countless books, whatnot, available. I'm partial to mine, but you can't go wrong with many of the others as well. There are plenty of ways for you to be able to go around and learn more about Android. That's where you can get these slides. Any additional questions?
Is there a cross-platform toolkit that you would recommend to what iOS and Android?
Yeah, can you repeat that very last piece? Could you
So
repeat that very last?
iOS and Android.
Well, let's put it this way. If I'm going to do cross-platform, I'm probably going PhoneGap. I will go more web and using PhoneGap as a stopgap until such time as maybe I can go pure web and maybe leave the PhoneGap scaffolding behind. That's more though my philosophy on how to deal with cross-platform, and that is I like to think that the web is going to be more the answer than say using something proprietary, that being said, that's more of a personal opinion more so than I can state that PhoneGap is the right answer for everyone across the
I have a client who wants to go native on those platforms and won't go
HTML. If it's a traditional app, and as opposed to a game, probably Titanium Mobile, I'm not a huge Titanium Mobile fan, but there is either that or go the Xamarin route if you're a Microsoft shop, and then you've got a lot of that experience, go look at them, the downside is the plugins for the mobile environments aren't open source, and that they aren't even free, so whether or not licensing fees may be an issue.
I have a question about the ecosystem is so large, there are so many different devices, so many different integrations. I understand that you can test on a real device, but testing on a real device is not enough because you need room for the device. So they provide the emulator, but the performance of the emulator is so poor that you can't actually use it.
Well, the emulator, there are, just as Android itself supports ARM and x86, so does the emulator. The emulator defaults to ARM, and that for maximum fidelity with the most Android devices. But that means it's converting ARM opcodes into x86 opcodes, because your notebook is not going to be running an ARM chipset most likely, unless you bought into a Chromebook. And so that gets slow. The x86 emulator, and is available for some Android OS versions, that is fairly quick. In fact, in many cases, it may be faster than real hardware, depending upon how powerful your development environment is. So the x86 emulator is not bad. The problem is it is an emulator, and so while you have internet access, you don't have emulated Wi-Fi. And so if you care about signal strength, access points, and so forth, you're not going to get it. The closer you get to hardware, the less likely the emulator is to work. There are services available that basically are cloud-based testing services. You upload your APK and your test suite, and they've got a room full of devices, and will fan your test suite out onto those and give you the answers back. And that the varying price points and capabilities. You can buy a bunch of devices. I've got 50 or so, and that they're mostly in this shoe bag thing I've got hanging over a door in my office, and they're very convenient, holding up lots of phones. But it's the sort of thing where, depending upon the deeper your app gets into the device, the more likely it is you're going to run into idiosyncrasies with some stuff. And that the simpler your app, the more likely it is that it's just going to work. And that you try it out, maybe you've got a phone and a tablet, plus you try some emulators for different OS levels, that maybe you hook up to one of the free services to see whether or not there's any gross problems, and that on other devices, even if you can't, write your own test suites and whatnot for them, and you call it good. And you then deal with the problems as they come up. You get the bug reports in, crash logs, and so forth, and say, okay, well, when running on, this particular Samsung device, I've got some sort of quirk, and that I'll have to deal with it. Also, it's another place where the reuse comes in, and that there's people like me and that who publish libraries and that whose mission in life is to try to deal with those device idiosyncrasies. Camera, for example, I have a library that's designed to try to smooth over the hardware differences and that in those cameras, and that because that tends to be one of the quirkier areas, and that's so that I deal with all of the quirks and that so you don't have to.
Is there any drawbacks diving into Xamarin style development, like cross-native, but at the same time building?
I'm not a .NET guy. I kind of left the Microsoft world back when I left C and C++, and so I haven't used it, and that it seems to be reasonably popular, and that and as far as I know, it's creating native UIs. But my depth in the Xamarin tool set and that is almost non-existent. Question behind you.
So the Java in Breakout traditionally was quite easy to reverse engineer. So can I just go to a Play Store, download the application and reverse engineer pretty much the original code?
Android apps can be reverse engineered, and that the bytecode languages tend to be easier to reverse engineer than opcode, like native C, C++ type stuff. And that there are various techniques for trying to minimize that. Personally, I tend to be of the approach of choose a business model where you don't care so much, but yes, reverse engineering is prevalent in Android, and that whether anyone's going to bother with your app versus any of the other million out in the Play Store is another thing. That's pretty much it, and that I'll be around here for a little while if you have additional questions. Next up is lunch down on the main area, and that's where the exhibit hall is. And that thank you all for attending, and enjoy the rest of the conference. And this is partly an integration point. It may be that you are trying to provide content in the form of a database structure or in the form of a stream, like a web service might do, and that you're trying to make this available to the operating system. If you want to deeply integrate with the Android search framework, you'll be able to pop up search suggestions when the user starts typing something into the global search field, and that you're going to wind up publishing one of these content providers that the operating system is going to consume in order to be able to figure out, hey, this is what we want to be able to blend in for the search suggestions. Or it could be for third parties. We consume a lot of content providers that the operating system publishes. Contacts, the call log, the list of all of the indexed multimedia assets, videos, photos, audio files, that sort of thing. Voicemails, calendars, all that stuff is published to us via system-provided content providers. We consume those content providers in our apps. You can even use content providers purely within your own application. It's kind of an abstraction layer. You want to hide all your database accesses behind a content provider to isolate it from the rest of the application. The rest of the application can simply deal with the opaque API that's published by that content provider, the details of all the actual SQL and all that stuff that's going on under the covers may be hidden behind that API published by that content provider. Android applications almost always have at least one activity. Whether they have any services, whether they have any broadcast receivers, whether they have any content providers, varies. Some applications will have all of these. Some applications will have none of these, and all the shades of proverbial gray in between. And so it will be up to you to decide as you are designing and implementing the application, what of these components am I going to need to be able to accomplish my aims? But again, we tend to fixate on the GUI end, and that after all, these phones and so forth, and that they've got the nice touch screens, and that we can show lots of interesting stuff to the user, receive input from the user, and so forth. And so a lot of time is spent on crafting these user interfaces. Activities are the coarse unit of user interface, the screen of the window. Widgets are the micro unit of user interface. Buttons, fields, checkboxes, radio buttons, scrolling lists, drop-down lists, all those things are going to be considered widgets. And an activity will have one or many widgets, usually on the many side. These widgets are then organized on the screen via what are known as layout managers, describing where the widgets are to be placed on this screen. There are layout managers that say, okay, we're going to have all these things be in rows or columns, so-called linear layout, giving you a box model, where you can say, okay, I want to have these in a row, million plus apps out on the Play Store, and that easily 3/4 of them are going to be traditional Java-based applications. Games is probably the biggest segment, and that which will not necessarily be using Java directly. They may be using other toolkits, which are in turn based on things like native code engines. But most apps is going to be focused on Java. Quick show of hands, how many of you speak at the Java? Okay, those of you who raised your hands, then you at some point in time learned Java. You took a Java course, you read it from a book, and that you had the SD card implanted behind your right ear that contained a copy of core Java, whatever. And when you learned Java, you started off indubitably with a public static void main method somewhere along the line, and that which you were told was the entry point for your application. And you probably wrote inside of their system out println hello world. That's the way you create a traditional Java application. But lots of Java development doesn't even do that. Many times when we're creating something in Java, it's really more of almost a plug-in to a larger framework. We are plugging into the Java web server or something like that for our web applications, in which case we're not writing the main, somebody else wrote the main that's in that framework we're plugging into. That's the same approach we take here in Android. We don't write a public static void main method anywhere. Frankly, I haven't even run into the public static void main method. I'm not even sure there is one in Android. There could be. And that we certainly don't deal with it. Instead, what we do is we create a basket of components. And we tell Android, through some metadata, hey, I have these components. Let's let the user do things with them. There are 4 major types of these components. The one that people tend to focus on is the activity. This is your coarse unit of user interface, roughly analogous to your screen, your page, your window, whatever terminology you're used to from other sorts of platforms and GUI frameworks and the like. An Android application can have one activity. It can have several activities, just as a web app could be a single-page web app, or it could be one that has lots of individual pages and that you are linking between. Either way works. We tend to think of Android activities as being a user transaction, that the activity is focused on a thing that the user is trying to accomplish. Disparate things tend to go in disparate activities. They don't have to, but they usually will. And so, settings versus help versus about are likely to be independent activities from whatever your main activity is. And it may be that the list of things in the main activity may wind up, or list of things in your application may wind up being a separate activity from the editing form that you're using to edit the information or things along those lines. And so you're going to be creating one or more of these. There is an activity class in Java that we will inherit from that describes what that activity is supposed to look and work like. But while activities get all the love because they are GUI and GUIs are fun, they're not the only components out there. The service in Android is designed for long-ish running background work. Things that aren't tied to the user interface, things that may even be spawning off on their own with no user interface in sight. If you're trying to set up some sort of a cron job, and that you want to do something every 15 minutes or something along those lines, you will probably wind up using an Android service for that. If you're trying to perform a longish running operation like downloading that ebook that the user bought from the store that your app is providing, well, you'll probably use a service for that download so the user isn't stuck having to sit and wait at your activity, waiting for the download to complete, that they can go off and do other things like, I don't know, take a phone call, and then do other things with their device while you in the background are sitting and chugging through, downloading the material. You can use this as an integration point to third-party apps. You can say, hey, third parties, you can talk to my activities, you can link to me the same way you can link to my web pages in the web app. You can invoke my services. I will do work on your behalf, and that you tell me the work you want to get done. That's part of my public API, and I will happily go do that work for you. There is the broadcast receiver. Broadcasts are messages that flip through the device, letting us know of things that are going on. Many of those messages come from the operating system itself. Hey, the battery's getting low. You may want to change your behavior. Maybe don't do as much work periodically in the background to help the user stretch out that last little bit of battery life. Hey, we had been on Wi-Fi, but the user got in the lift and we lost our signal. We fell over to mobile data. And you may care about that. If you have the long-running socket connection and that for your streaming audio, you're going to need to know, okay, I'm going to need to reestablish that socket and maybe do slightly different configuration, and that now that I'm on mobile data rather than Wi-Fi, you'll choose a lower bandwidth stream or things along those lines. Also ways for applications to send and receive application level broadcasts. Maybe part of your integration strategy with third-party apps is that you're going to send out broadcasts when certain events occur within your app that third parties may care about. You're making that music player, maybe you're sending broadcasts indicating, hey, we just switched to the next song. So that if third parties are interested in knowing that because they want to be able to show that information to the user in addition to your app showing that information, that they have the information that they can turn around and actually show. Content providers provide content. Okay, so good morning, everyone. Good morning. Hey, that was a better reaction than keynotes got. And obviously that coffee had an impact. My name's Mark Murphy, and I'm here to talk to you about Android development. Now, presumably, most of you who are here are new to Android development. You maybe haven't done mobile development yet. Maybe you've done mobile development but for other fruit-flavored platforms. And that, in which case, this is a great presentation for you. We will cover an overview of how Android apps are put together, and that so you can have some idea of what you will be dealing with. But this is, of course, a wonderful area to get into. We've shipped 1 billion Android devices and more so far. In fact, probably enough more that we're probably up to 1 billion users of Android devices by about now. And so there are a lot of people out there for whom you can get your apps together. Some of you may already know Android development and are here because you thought this was the North Rotunda, the South Rotunda. North Rotunda is the other end of the hall. And that I promise that I will do my level best to intersperse enough humor to keep you from falling asleep, though if you do fall asleep, we reserve the right to poke you in the ribs if you start snoring. A few administrative things before we get started. You were all given thumb drives when you got here, which purport to contain a copy of these slides. They contain a copy of these slides from about 2 weeks ago. I was editing these slides yesterday. There will be a QR code and URL at the end that you'll be able to download the exact set of slides that I'm going to be showing you here. If you're the sort who you can't attend a presentation without having the slides right in front of you, speakerdeck.com/commons guy, that's me, and you'll be able to get the presentation from there. This presentation is being recorded in front of a live studio audience, and so pay no attention to that camera in the back, other than those of you who are kind of dead center in the room. If you do feel the need to get up and leave, could you maybe like put the ball out or something? I'm sure they'd appreciate it, and not blocking the camera. If you have questions anywhere along the lines, raise your hands, wave frantically, throw soft objects at me, whatever it takes to get my attention. So if you throw things at me, if there would be things that are non-staining, I would appreciate it. And with that, let's start talking more about Android. I'm going to spend most of the time of this presentation talking about the traditional Android development model. That involves healthy doses of Java, XML, and other things. We will spend some time, though, on other development environments that you can use in order to create your Android applications. If, for one reason or another, you do not feel that the Java approach that I'm outlining is necessarily your cup of proverbial tea. But again, most Android development is based off of Java. And that's where, if you go to the Play Store, or a column, I want to apportion the space inside of that row or column, between these widgets in a certain way, 50% to this one, 25 and 25 to the other two, things like that. We've got layout managers that implement rules where you can position things relative to other stuff, so-called relative layout. I want to position this to be 10 pixels down and 20 pixels over from the left off to the screen itself. I want to position this widget to the right of and on the same horizontal plane as this other widget. I'm anchoring widgets to each other. Layouts that put things into tables and grids. You can create your own layout managers that implement your own business rules if you're finding it difficult to hammer your UI into the various boxes of the built-in layout manager supplied by Android. And there's plenty of third parties who create widgets and create layout managers. You'll be able to download their code, integrate it into your own apps, and that in order to be able to leverage their expertise. Usually we're going to craft these user interfaces as XML files, whether manually or through a drag and drop GUI builder, depending upon your development tools. We'll talk more about development tools in a bit. It's possible for you to be able to create your Android applications with a GUI that you're assembling purely within Java code. That's a little weird. It's along the lines of implementing your web app in assembler, but hey, it's a free country, and that you can do what you want, and so there will be people who will purely develop their UI in Java. Most developers will use these layout files. And we'll take a look at one of these layout files in a little bit. I'm going to fire up two of the major IDEs in Android and walk through the wizards for setting up your initial project, and we'll take a look at some of the files that get output as a result.
Is there any connection between the GWT libraries and building manual layout manager?
The question is there any connection between GWT and doing things, manual layout in Android and Java? They're both made by Google. Beyond that, not really. Are there similarities? Sure, because they both kind of looked at Java Swing and that, as part of their inspiration, plus a little bit of web as part of their inspiration, and so there's going to be some commonalities, but that's more of a fact of where they came from more so than there seems to be an intentional design decision of, okay, we're going to attempt to make these things be similar. And that I'm not aware that the GWT team talks to the Android team any more than any other two teams at Google necessarily talk to each other.
In case of these basic components, how can we interact with the inbuilt devices like camera or something like that?
We'll talk a little bit more about those later on, but there's a series of Java classes in general that will allow you to get at the camera, get at the accelerometer and other sorts of sensors